Hi everyone, this is how to deal with the tetrahedral style of stereochemistry problem. Here we have our example, CH4. There's the molecular formula. What I need to do first is draw the Lewis diagram for this molecule. I'm going to go pretty fast. You yourself might need to slow down a little bit in order to come up with the Lewis diagram. However, it's really going to help us apply this table and wrap our heads around what we're trying to do. The Lewis diagram shows any place that they're sharing as a dash, and all lone pairs are shown. Turns out that methane here, the hydrogen and the carbon, none of them have any lone pairs. So this is the Lewis diagram for a methane molecule. What I need to do now is analyze it in order to find the central atom. It really does stand out. A central atom is something that's between some stuff. The hydrogens here are around the outside. They're only attached to one thing. They're each attached to the carbon. Whereas the carbon, it's a no-brainer. It's in the middle. It's the central atom. We need to think about that central atom in two ways. Does this carbon have any lone pairs? It doesn't. And how many bond locations do we see? It has 4 single bonds, 0 lone pairs, and 4 bond locations is what we call a tetrahedral. It's going to give a tetrahedral shape, which looks like this. I have a small one. A tetrahedral shape. In order to draw that, there's certain things to keep in mind. The central atom goes in the spot. Okay? What we want to do is, there's going to be 2 of the atoms are in the same plane as the carbon, which looks like this. We're going to have two of the hydrogens with a regular bond, with this regular solid line dash. And then the other bonds are quite specific. One of them has a wedge shape, and one of them has a dotted line. The wedge shape is to show that it's coming out of the board, out of your paper, at you. And the dotted line is going into the board, trying to show 3 dimensions. When we look at the picture, we see that there's the central atom, and one of the hydrogens is above the central atom, and 3 of them are below. 2 of the bonds are regular solid line dashes. One of them gets this wedge-shaped, this triangular-shaped bond, and one of them gets a dotted line. Things to remember are, there's always 1 atom above the central atom and 3 below. 2 solids, 1 wedge, and 1 dotted line. Which one is which doesn't matter actually. So I can, as long as I have this same overall shape, I can change which bond goes where and still be totally correct. So let me redraw this in a slightly different way. Here. It starts to look a little bit messier because I was going a little bit fast, but the overall theme is the same. We have our central atom, one of the hydrogens is above it, 3 of the hydrogens are below. There's 2 regular lines, 2 dashes. They're both here on the bottom. There's 1 wedge-shaped dash, wedge-shaped bond, a triangular sort of shaped bond, whatever you'd like to call it, and a dotted line bond. Tetrahedral always looks like that. 1 above, 3 below, 2 solid lines, a dotted line, and a wedge-shaped line. A tetrahedral shape. It's when the central atom has 0 lone pairs and 4 bond locations. And our standard example for that is methane. And I hope that helps.